I'm connected. It just connected me. Why are you not connected? Good morning, Zach.
Good morning.
Good morning, Ella. Good morning, Ada.
Good morning.
Hey, Tenzin. How's it going? I think this one, if I'm looking at my chart, yes, that one that's wet there. So if you want to grab some paper towel and wipe it on down. Awesome. Woohoo.
Did you hear that we're going back to distance learning?
Yeah.
What a bummer.
But it will be so much safer.
Yeah, it'll be safer though.
Oh. Yeah, we'll talk about that some in a minute too. Once we get everybody here. Ah, you're in. Nice. I love it. Good morning, Faduma. Good morning, Ilhan.
Good morning.
That's our lovely 1-minute warning bell. I bet you guys miss that every day, right? Mhm. Good morning. Good morning. Awesome. Good morning. The lighting looks like you have like halos. It's beautiful. Good morning. Good morning, good morning. That's a good point. Sometimes it would be nice to have that 1 minute warning to make sure you're on time to the online class. Good point. Oh, nice, nice. Hello, hello, hello. So many beautiful sunny faces on a very not sunny day. You guys ready for the snow? No, me neither. Snow and ice, I'm not excited. Good. Some are already like popping stuff into the chat about the starter question, which is crazy fast. Go ahead, we're gonna do now. We're gonna start talking through bits of it and you're gonna start participating with me in the chat in just a little bit as well. Nice. And the balanced equation can be difficult sometimes. So let's, for the chat, just say that we'll do the, just doing the coefficients with colon in between. That'll be the easiest way for that. Good morning. Good morning, good morning, good morning. Okay, this acid-base stuff really brings us back to a whole bunch of different topics from last year. So I'm going to be quizzing you guys with the chat. So be active in that chat with the questions that I'm asking. So I know if we remember this super old stuff, I mean, some of it goes back to first quarter of last year. So this is gonna be a ton that we're going through and you are gonna be shocked by how much you remember. It's gonna be amazing. So we first want to get to our whiteboard here. We are looking at sulfuric acid with zinc. Sulfuric acid with zinc. So if we look at the periodic table, what's the symbol for zinc? Go ahead, type it in. Nice, 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 nice. Awesome. Beautiful, folks. ZN indeed. Now, my wondering for you, is that a solid, liquid, gas, or aqueous in normal state? So would I have a chunk of zinc? Would I have gas zinc floating around me? Would I have a liquid zinc around me? What do you think? I agree, I'd have a chunk or solid. So I'm gonna put an S behind here. So I've got my zinc, that's a solid, reacting with sulfuric acid. And I'm gonna tell you a hint of something that it took me a long time through my first year of chemistry in high school to figure this out. I hated memorizing the polyatomic ion charges. They're those weird like letter, subscript, superscript. I had such trouble with that. But later on in the year, we talked about acids and bases. And for some reason, memorizing the symbols of the base or the acids made it so much easier for me to remember the charges of the polyatomic ions. I don't know why, it just was. So for some reason, I knew right away that sulfuric acid was H2SO4. And that came from the fact that hydrogen has a charge and the sulfate ion has a charge. Type into the chat, what is the charge of hydrogen? Or we could say, what is the oxidation state of hydrogen? Nice, yeah, it's a +1. So this hydrogen, there's two of them that have a +1 charge. And a compound overall, what charge does that have to be? Type it into the chat. A compound overall, after it's all bonded, nice, it's 0. Good, so overall we have to equal 0. And so we can deduce what this SO4 is. by knowing that I have 2 of my positive 1s and that I have to equal 0 in the end. So type into the chat, what's the charge of the SO4 polyatomic ion? Nice, -2, exactly. So I have SO4 2 negative and H1 positive, and that gave me the H2SO4. Again, that was just a way for me to figure it out. For some reason, memorizing the acids later on in the year was so much easier than memorizing the polyatomic ions with their charges. And so it made me realize, well, if it's always with an H plus, because that's the acid part of it, I can easily deduce the charge of the ion either by doing a little bit of algebra or just by looking at that 2 right there. I know the hydrogens have to be a positive 1. I know that that 2 came from the fact that I need to cancel out a -2. So that's a couple ways to think of it. Good question. There's a question about the rest of the oxidation numbers, like of sulfur and oxygen. We'll talk about that more later on. I don't want to get into that one quite yet. Okay. All acids are going to be a specific state. What do you suppose it is? A solid, liquid, gas, or aqueous? Beautiful. It is aqueous. So all acids are going to be aqueous. They're dissolved in water. And that's how they can behave like acids. So if they're donating hydrogen, they're doing that by getting more H3O1 positives in solution. So all acids are going to have to be aqueous. Good. Okay, so my zinc and my sulfuric acid. What happens here is the zinc, which is a single element, comes in and kicks out the other cation. So type into the chat, what is a cation? Yeah, it's a positively charged ion. How did it become positively charged? Go ahead, type that in too. How did it become positively charged? Nice. It's losing electrons. It's exactly right. By losing electrons. And since I didn't have any of you last year, I'm going to tell you my way for remembering cations and anions. It's silly. It's silly, but it makes sense since you guys know me and you know trillion so well. I remember cations as cations are positive. Or I positively love cations. You gotta love dad puns, right? I positively love cations. They're positively charged. And then for anions, I just actually break the word apart because it is a negative ion. Anion, a negative ion. So those are my 2 little tricks of the trade. Okay. So we've got zinc coming in and kicking out the other cation. So a cation displacing another cation. Cation kicks out the other cation. So go ahead, type into the chat, what kind of general reaction is this? When you have one thing kicking out another to form one thing on its own and another thing. Awesome. I'm seeing a couple different things. I am seeing a substitution, which it would be, absolutely, or single displacement. Displacement. MENT, there we go, or replacement. Or we could call it a single substitution. Oh my goodness. So all of those are things that we could name them. Nice. Good, good, good. And that's okay if you forgot that, because that's way, 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 way long ago. That's why we're doing some reviewing now. Okay, so now we're going to predict the products. Hydrogen is now on its own. Is it okay if I just do that? I see some head shaking no. I see some no's in the chat, and I also see what it should be in the chat. Very good. Yes, hydrogen is one of the diatomics, or as I like to call them, the magic 7. The reason I call them the magic 7 is because there are 7 of them. They kind of make a 7 on the periodic table. We have hydrogen way over here, which is the annoying one. But starting at number 7, if you look at the periodic table, number 7 is nitrogen. So nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. There are 7 of them. They kind of make a 7, except for the weird hydrogen. So they're my magic 7, and hydrogen is one of them. So it has to be H2, otherwise it's not going to be stable. Yeah, Brinkelhoff. Dr. Brinkelhoff is another way of memorizing it. Good. Good, good, good. Okay. Hydrogen, is that a solid, liquid, or gas at room temperature? Yeah, absolutely. Hello, it is a gas at room temperature. Beautiful. So we've got that gas at room temperature, and now we have to figure out the other product. So in the statement at the very beginning, it said what the common oxidation state of zinc was. Can anybody remember what that was? I know it's not on the screen right now, but good. Yeah, so I said that the common oxidation state of zinc is a 2+. A 2+. You don't need to memorize that. It was given to you in the problem. It's just that I happened to move off the problem. Sorry about that, but I'm glad some of you remembered it anyways. So zinc is a 2+. And I figured out over here that SO4 is a 2-. So even though I had forgotten that that's what its charge was, I deduced it because I knew that sulfuric acid was H2SO4. So I have SO4, 2-. Excuse me. Those cancel out right away, right? So 2 minus 2 is 0. A compound's supposed to be 0. So I really just need 1 and 1 to be a stable compound. ZnSO4. And there's going to be some leftover water in the solution that I don't need to write out as a plus H2O, but I do have to indicate it somehow else. How do you suppose I should indicate that there's water in here as well? Yeah, I'm going to put an aqueous here. That zinc sulfate, it's dissolved in the solution. So I'm going to say that it's aqueous. That's all of the parts that I need except for balancing. So take a moment to balance, and then when you know what it's going to be, type it into the chat. I know I've already seen a few answers for it. You can do it in the format of words. You could do it in the format of like coefficient dot dot coefficient dot dot coefficient dot dot coefficient, because we all have it written the same way. So we wouldn't have to write out the whole thing. And I'm seeing it in some words here because there's a super easy way to just say it in words. So let's get a few more. I'm gonna wait for just a few more answers in the chat. Seeing lots of good things already. Good, good, good. Yeah, beautiful. Yeah, I'm not trying to be tricky here. It is actually already balanced. So those of you that put a 1, 1, 1, 1, you've got it perfect. If you wrote it out, already balanced, that's perfect as well. We do want to indicate though that we did go through the process of making sure that we knew that it was balanced so that somebody that's grading it doesn't think that you just predicted products and didn't bother to try to balance it. So just writing out already balanced is a good way to go. What questions do you have about all of this review stuff? Oh my goodness, so much review right there. Guys, we covered like the whole first semester and part of the second semester worth of chemistry content in that little bit right there. You guys did so well.